3D measurement toward virtually reality in agriculture. And also right now we already have around 57 participants from students, several lecturers from agriculture engineer department, and also from general participants in a Zoom room. The first of all, I say thanks to God we have given us an easy limit pandemic so we can be together virtually and participate in this special occasion. Hopefully without any obstacles to the Honorable Speaker, Prof. Suyoshi Okoyama, and to the Honorable Dr. Ahmad Adi Sulianto as the head of Agriculture Engineer Department, to the Honorable Dr. Mustafa Lutfi as the head of Agriculture and Biosystem Engineering Study Program, and all participants. Before we going to the main event, I would like to remind all participants to obey the housekeeping rules. The first, all participants were required to write the name on the Zoom according the format is name underscore institution. So to all participants whose name does not fully the format yet, please change your name and rename it when the event is still ongoing and can run it on with when the moderator invite you. Then you I'm sorry. Okay, before we go to the main event, let me introduce you to the rundown of this event. This event will start with opening and then continue to welcoming speech from head of Agriculture Department, Dr. Ahmad Adi Sulianto.
Thank you. My voice is clear enough.
With
yes, Pak Adi.
Yeah, Pak Adi.
To Dr. Ahmad Adi Sulianto, the time is yours.
Okay. Thank you very much, Master of Ceremony, Risti. And I would like to welcome to our department, Agricultural Engineering Department, Faculty of Agricultural Technology, Universitas Brawijaya, to Okayama Sensei, Yokoso Sensei. We are very glad and very happy to be with you now in the web-based seminar with the topic Measurement Toward Virtual Reality in Agriculture. Honestly, now we face a 4.0 generation. That means that the automation also force us in the field of the agriculture, makes us to do the precision of agriculture. That is why this is the first step for the collaboration, I think. And I would like to make the detail and the deeper collaboration between Universitas Brawijaya, especially Department of Agricultural Engineering, and also with the Okayama Sensei, because we have a junior lecturer that potentially to be a PhD student in Japan, especially in Ibaraki University. So, for example, Mr. Iqbal is the potential student, PhD student. So please, we would like us, Okayama Sensei, our junior lecturer, have a chance to be your student in the near future. And this web-based seminar is as the first step to be a first collaboration between us. So the precision agriculture is must, and we should try and learn deeper and deeper, because in Indonesia nowadays we have faced a problem about the limitation of the field and also limitation of resources. And in the urban area especially, we should try to have yes, effects about the automation and also precision agriculture to use effectively resources in our environment. I think it's all from me, and thank you again for the Okayama Sensei, and wassalamualaikum warahmatullahi wabarakatuh. Okay.
Thank you, Dr. Adi Sulianto, for the speech. Okay, so before we to do the main season, I would like to introduce the moderator today. This international guest lecture will be taken over by Dr. Dimas Firmanda Ariza. Dr. Dimas Firmanda Ariza is a lecturer for Agriculture Engineering Department. So without further ado, I would like to give a very warm welcome to Dr. Dimas Firmanda Ariza. To Dr. Dimas Firmanda Ariza, time is yours.
Okay, thank you very much, Haristia, for the introduction. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. I'm Dimas. I will be your moderator for today's international guest lecture. I'm very happy because we can still carry out the international guest lecture, even though it is still in a pandemic condition. I would like to welcome all of the lecturers in the Faculty of Agricultural Technology, and I also would like to welcome all of the participants from a different part of Indonesia. And I also noticed here we have participants from Japan, from Kyoto University, and also we have participants from UK, from Nottingham University. Okay, before we start the main lecture, I would like to introduce you to our speakers today. His name is Professor Tsuyoshi Okayama. You could call him Okayama Sensei. He got his bachelor degree, master degree, and doctoral degree from Osaka Prefectural University. And he also have experience as a postdoctoral fellow in Osaka Prefectural University, also in Ohio State University in USA. And currently he is a full professor in Ibaraki University. Hello, Okayama Sensei. Could you hear my voice?
Yes.
Okay, I guess, Okayama Sensei, now is October 21st. Maybe soon in Ibaraki and also Kyoto, the leaf color will be changed to red.
Yes.
It will be
yes.
beautiful there.
Yeah.
I really miss.
Yeah. So you miss the beautiful scene.
Yeah.
Aren't you?
Yeah. In Kyoto.
Yeah. Especially Kyoto has a very good. Yeah.
Yeah.
Very nice season.
We hope. Momiji, I really miss Momiji.
Momiji, yes, Momiji.
Yes. So I hope that we will still have a chance to visit Japan again.
Yes. So
okay.
Yeah.
Okay. The topic. Okay. The topic of our international guest lecture today will be about 3D measurement towards virtual reality in agriculture. I think it is an interesting topic for our students because now we are moving towards agriculture 4.0, or even in Japan, already Society 5.0, you all already talk about Society 5.0. So without further ado, please, Okayama Sensei, time and place is yours.
Okay, thank you. Thank you very much for introduction. And I'm very happy to having this opportunity. And thank you for Dr. Dimas and Dr. Yusuf, and thank you, Iqbal. So, okay, let's start my presentation. So I don't think it's a very like official presentation. I'm very so I made my presentation is very casual way. I'm very sorry. And today's content, so the Dr. Dimas, so thank you for introduction. So first I introduce my university, Berkeley University, and shortly I will give you my self-introduction and the cyber physical systems. And the first one is the 3D measurements for especially strawberry. And we have two methods to get the 3D information, and one is the depth camera and one is photogrammetry. And finally, I will share my idea to you about virtual reality for agriculture. Okay, so my Ibaraki University has 5 colleges. One is humanities and social science and education, science and engineering, and agriculture. And Ibaraki University has also 3 campuses. One is located Hitachi, and one is the Mito, and our campus is Amimachi. Amimachi is located from only 60 kilometers from Tokyo Station, so very near from Tokyo. And also some young students has interest in Tokyo Resort, Disney Resort. Tokyo Disney Resort is also very near from our campus. Then you can go to only 1 hour from drive. And the number of undergraduate students is around 7,000, and graduate students is about 1,000. And the next, I introduce my College of Agriculture. So our college has 2 departments. One is Department of Food and Life Science. The other one is Department of Regional and Comprehensive Agriculture. I belong to this department. And so our college is very small. Maybe the smallest agriculture college in Japan, National University, Japan. And the number of undergraduate students is only 700, and graduate students maybe around 120. Very small college. And we have also the experimental field very near from the campus. In the fields, so we have many systems and devices for the precision agriculture. Well, we call it the smart agriculture. Maybe in Indonesia also. For example, the GPS guide system for tractor and robot mower and the field server to measure some environmental informations, and also behavior monitoring system for cow, Wagyu, Japanese beef, and also there are some devices to measure the soil parameters, and also the drones for fertilizer and monitoring. So the experimental field has totally around 22 hectares. I think I don't know. In Indonesia, it's maybe small, but in Japan, it's a very large scale. And so I introduce my research history. So I am working on about the biosystem derived algorithm. It's really difficult to explain. But for example, genetic algorithm and the neural network. Neural network is so currently maybe some of researchers use a deep learning. So deep learning is a very advanced neural network. Neural network is a very primitive one. And from 2003, so I'm working with Professor Shibusawa. He's a very famous researcher in precision agriculture. So we are developing real-time soil sensor. And from 2006, I'm working on the plant factory project. So where the genetic modified lettuce is produced. So the lettuce created the vaccine for piglet disease. It's a very interesting project. Then from 2010, I moved to Ibaraki University, and I'm started to study about the 3D measurements and the virtual reality. So which I introduced to you today. And so we have, so I have two bosses. One is Professor Murase, the Dr. Yusuf, also his boss is Dr. Murase, and so Dr. Shibusawa. And so now, currently, so we are trying to many things using the 3D measurements. And for example, for animals, so the predicting calving timing of Wagyu with a depth sensor, or so I just published the papers to estimate the body weight of pig with a depth sensor, and monitoring behavior of a mouse. It's a little bit different topic of our agricultural engineering, but the animal experiment is a very, very important to create it for some medicine or some, food. And about plants, we are monitoring strawberries and rice and the cabbage using a drone. So I published the smart garden, the future gardening system, smart garden. It's a very exaggerated title. So but I'm very embarrassed title. But so yeah, but yes, I will explain a little bit this smart garden. So this smart garden, we use augmented reality technologies. So so today's topic is about the mixed reality. So we have the real environment and the virtual reality. Augmented reality is around here. So and using here's marker. So we call it markers to get the position of cameras using these markers. So put the markers around here. Then so we capture the location of camera. Then so we overlay the computer graphics on the real images. For example, so we put the the location should be planted some, I don't know, the tomato or cabbage or the pepper, or then so maybe so you should put the fertilizer here, but actually we cannot see the soil in the soil, of course. But so in order to use the computer graphics, so maybe some imagination should be give the farmers or some amateurs for gardening. Then for the other application is the overlay some virtual the tomato plants. Then if you overlay this virtual tomato plants, so you can compare the easily real tomato plants and the virtual, for example, the ideal tomato plants or disease tomato plants. So that the farmer can get the intuition of the condition of tomato plants. Yeah, this is my idea of smart garden. Then so today, so this is the concept of the smart garden. So we have two spaces. One is the real, of course, real environment we live in now. The other one is virtual reality. So sometimes we call it the cyberspace. Then, so from the real environment, data is collected. Then, so data should be organized spatially or timely in the virtual space. Then some simulation has been conducted to get the optimum strategy or some treatments. Then, so in the real environment, this result of simulation should be validated. So this is the concept of the smart garden. Then, so it's a very similar thinking. So I explain Society 5.0. Some of guys maybe already know what is 5.0. And this is the picture from the Japanese government. So Society 1.0 is hunting and gathering. It's a very, very primitive society. The Society 2.0 means agriculture society. Then 3.0 is an industrial society. Then 4.0 means information society. Maybe so we living around here now. So we have internet, and actually so we can communicate through the internet, and we can have this kind of nice seminar using the internet. I think 4.0. Then so Japanese government or some researchers said, so the Society 5.0 is coming. So it's a little bit difficult to explain. So what's the difference between Society 4.0 and 5.0? But yeah, so I recommend it to Japanese animation to use. So I'm very sorry. I'm very sorry. I told you I don't think it's a very official seminar, but I think it's a very casual one. So I introduce my favorite Japanese animations. And one is in Japanese, the Denno coil. So it's in English, the coil a circle of children. It's a very interesting. So so this glasses is a special device for augmented reality. Maybe so this dog is a virtual. So if you can see this dog if you with a glasses, but without glasses you cannot see the dog. Also this, I don't know, the strange animals. So it's a very and the other one is Ghost in the Shell. Maybe some guys knows if you like science fiction. This animation is also very interesting and very informative for cyber physical system. Cyber physical system. I'm sorry. Cyber physical system means almost the same meanings of 5.0, Society 5.0 to me. And so this is a very simple explanation of what is cyber physical systems. So, but I explained that before, the smart garden system, it's a very similar. So we have two worlds. One is physical world and the virtual reality. In the physical system, physical world, we have a very complex problems. We have very complex systems, so too many factors and too complicated relationship, etc. Then, so in the virtual reality, so we simplify the problems and simulate it. Then, so reduce the number of factors of the simplified relationship. Then we can get some solutions. So abstraction is very, very important to get the useful solutions. The abstraction is very, very difficult. And so in order to communicate virtual reality and the physical world, so we use IoT, Internet of Things, or then so I'm very focused on the 3D measurements. Then so I talked to the 3D measurements. So there are so many ways to get a 3D information, I think, but so I focus on the two ways of 3D measurement. One is depth camera, depth sensors. Sometimes they call depth sensors. And the other one is a photogrammetry. So I introduced depth camera, history of depth camera. So around 2008, so the depth camera is a very expensive. It cost 5,000 US dollars. And in 2010, the Microsoft produced a Kinect. Maybe some of you knows it's a device with a gaming machine, Xbox. So it just costs 150 US dollar, very cheap. And also the performance of this depth camera is much better than the SR4000. It's a revolutionary event. Then still, now 2021, the Microsoft continue to make depth camera. The recent one is Kinect Azure. Kinect Azure is put in the HoloLens. It's a head-mount display. So in the head-mount display, so it has the same camera Kinect here. And Asus is also made some depth camera. And currently, the Apple is focused on the very small depth sensors on the mobile phone or iPad or iPhone 12 iPhone. And Intel also made some depth camera, but so recently announced that Intel will quit to create the depth camera. But I don't know. So I don't know what will go on in the near future. So I share you some example of the very latest version of LiDAR, so installed in an iPad or iPhone. So maybe some of you already has this kind of cutting edge device. So using your device, you can get the 3D information very easily. So I'm very surprised. So maybe you can use this kind of technique to the agriculture. Then so I explain so what the significance of depth sensors. So human eyes, we capture some objects in 3D using our two eyes. Then so we make we decide subjectively. Then so 2D camera of course capture the object in 3D, only can capture object in 3D, and depth camera can capture object in 3D like us. So it's a very good. And also that this is a very good point is the depth camera. So we can decide objectively using the information from the depth camera. It's a very good point of depth sensor. But however, so recently, so camera is very cheap, and we can get the many images from internet or many sources. So maybe so 2D camera also is a promising using objective decision using the deep learning was something. Yeah. Then so I introduce about the 3D measurement for strawberry plants. So strawberry in Japan strawberry is a very famous fruit in Japan. So Japanese maker. So some resources said so Japanese eat raw strawberry fruits very much, and maybe the amount of the fruits is the biggest and the highest in the world. And also Japanese create the 300 varieties of Japanese strawberries. Maybe the half of varieties in the world is Japanese varieties. And so I use two methods for 3D measurements. And one is depth camera, Intel RealSense 415, and the other one is photogrammetry using the very usual camera like this. So maybe if you want to use the photogrammetry, so you can use your smartphone. Then the monitoring situation is like this. So the problem of the depth camera is, so this camera uses infrared light. It means so it is a little bit difficult to use the under sunshine. The sunshine includes a lot of infrared, so it is a little bit difficult. So I conducted the experiment in the indoor. Then, so I use this kind of LED because the chlorophyll can absorb red light and blue light. So this light looks like a purple. Then, so this is a mechanism to measure the depth camera. So fundamentally, so this camera uses 2 cameras, stereoscopic. Then, so also the IR projector is projected as a random dot. So we call it random dot to match the 2 images. Then get the depth camera, the depth information. Depth means the it's a kind of distance from camera to object, but it's so it's a little bit difficult to distance and depth. Depth means so it's kind of the plane of the camera, and so this distance we call it depth, not range. So this is the example of the 3D information. So that 3D information, we call it the point cloud. Point cloud is the collection of points. So if you use a depth camera, so this kind of 3D information get very easily. And even the dark periods, so we can get the 3D information like this. But a little bit, so to compare the light period, the point cloud in the dark period is a little bit rough and not so clear than the point cloud in a light period. Then I explained the photogrammetry. The very famous method of photogrammetry is structure from motion and multi-view stereo method. So shortly, the SFMVS. It's a very famous method of photogrammetry. So in order to get the 3D information, first, so you should get the many pictures from different angles like this. So using these many images, so using some softwares, so we can get the 3D information, 3D model like this. Then, so we get the images like this. So about 200 images, 6,000 times 4,000 pixels and JPEG format. Then using a Pix4D mapper, it's one of the photogrammetric software. Using this software, so we can get the point cloud like this. So this is an example of the point cloud. See, so so if we use photogrammetry methods, so we can get the very clear 3D information. So compared to the depth camera. Of course, so we get the images from different angles. So we can get more wide region than the depth camera. Depth camera is fixed only one place. So the point cloud from the depth camera is very limited. Of course, the backside information cannot be obtained, of course. Then, so I study some studies has conducted. So today I introduce some water stress reaction experiments. So we prepared 6 pots, and so 3 pots are controlled, not under stress. So the 3 pots is under stress. A very simple experiment. Then so I measure the soil moisture using these soil moisture sensors, and so here is control. Here is under stress treatment. About 11 days for for water stress. Then this is the change of number of points. Number of points means that the point clouds. I told you the number of point clouds is consisted of the points. The points is changed like this. But so you know this up and down is because of the light period and the dark period. Then so water around here, so maybe cause of water stress, the number of points is decreasing like this. Then the when stop the water stress, they recovery like this. So this is a difference of point clouds between the light period and the dark period, a little bit different. Then also I check the height of point clouds. So under stress, the plants, the height is decreased because of wilting, like this. So this is the extracted point cloud of strawberry plants. It's a control treatment. So there is no change during the experimental period. Then here is under stress, the strawberry plants. So you know the day 4 means the water stress the period. So here is a little bit. So you know the number of points is decreased, and the shape is changing. So because of wilting. Yeah. So but maybe so we can get the, some information from the point clouds, so which represented the water stress. But so there is problems of the measurements, 3D measurements. The one is the 3D measurement can measure the, of course, only surface information. Get only surface information can be obtained. Yeah, this is the occlusion problem. We call it the occlusion problem. Therefore, the plant structure inside canopy may not be, can be unknown. So it is necessary to estimate the plant structure in the unknown area if we want to know. And the second is only point cloud can be obtained. So it's a little bit, so it's not good expression. So just point. We can get the just positions, but maybe so we want to know more functional informations. Yeah, then so it is necessary to give meaning to the obtained points. So this point means a leaf, or this point is stem, or maybe this shape is wilting, or this shape is good condition, or bad condition is something like this. So this thinking is a functional structure plant model. So for example, the Dr. Sivanen mentioned about the structure from functional structure plant models. Then so finally, so I explained the virtual reality for agriculture. So then this is a cyber physical systems again. So in order to create virtual reality in agriculture, so maybe with depth camera or photogrammetry, we can get the 3D information, but only it's just a structure. But we want to know that maybe the motion or the growth, yeah. So it change timely. So in order to make a virtual reality, we want to have this another one dimension, time dimension, in addition to the 3D informations. So so how to create a virtual reality? It's a very, very difficult problem then, but currently, so we can have a very nice tool. So it's a game engine. So game engine is a tool to create the game. And so there is two major game engines in the world, and one is Unity, and the other one is Unreal Engine. Then so currently, so the whole in the world, so auto driving simulation is very popular, and but so Unity is used as a simulation of auto driving simulations, because so Unity is a very, very good performance. So for example, so this scene is a very realistic. So Unity can create a very realistic scenes, and it calculates it very fast, because so as you know, the recent game is a very, very realistic and very complicated, and many players plays in the simultaneously. So it should be calculated very rapidly. So this performance is very, very suitable for auto driving simulations. Then so again, so how to create a virtual reality for agriculture? So the game engine is a very good tool, but so in order to virtual reality, we need some objects. So the objects call it assets in the game engines. For example, to create the agriculture simulation, so maybe the crop or livestock or insects, disease, and agriculture machinery, or soil, light, temperature, humidity, or rain, or so anything. So anything what you want to put in the virtual reality. So we need these assets to create a virtual reality. Then so now it's a very, very primitive, and so just started to just start my project. So now I'm trying to create the strawberry asset model using digital content creation tools. Maybe this is a application to create the assets for game engine. Maybe so you are the engineering students. Maybe you can use AutoCAD or SolidWorks or some other computer-aided some software, but it's kind of something like this, but it's for game engine. Then so so we are trying to modeling strawberry. It's a very primitive one. I'm very sorry for that. The feature of the model is one is size and shape and color, so can be expressed using this model. So I explained how to make a model using this software. The first make a mid-leaf, and the second is set length of veins using the B-spline curves. And then so set angles between the mid-leaf and veins like this, also using a B-spline curve. And then set the curve of the leaves. So I don't know if the curve is the suitable word for this, but so it's a curve using a spline curve. Then create a mesh like this, and so assume to be symmetric shape. Then so we use mirroring the like this. Then so this is modeling for of a leaf. So this is a good thing. So because if you want to create some leaves in using a digital content tool, maybe it's a very manually structures. Maybe so. It is very difficult to explain, but you manually create things like a curve, and so it is very difficult to make the same object. But so this Houdini is a very procedural way, and so you can modify the very easily and using some parameters, the numbers, to change the shape or curves. Then so unfortunately, I don't have good tool to adjust parameters automatically so far. So it's very unfortunately I adjust parameters manually. So it's a very big problem. It's very big problem to solve the very near future. Then so we make some motion using the keyframes. Keyframes, so it is very difficult to explain. So it's a kind of jargon of the digital content creation tools. Then so this is example of the simulation growth model of leaf shape. Yeah, to me, so it's a very complicated shape of a leaf, but so it can be expressed using the parameters like this. Then so the strawberry plant is a trifoliate leaf. So then we create the tree and leaves like this. Then using the very similar way to create the trifoliate. Then so this is example of some motion of trifoliate leaves. Maybe so in near future, so we can quantify the condition of leaves using this kind of models. So this is actual models which is captured using the photogrammetry method. So maybe so I think so this model can express the shape really precisely, because I adjust the parameters manually, so it is of course. So this is the final slide. So in future agriculture means this is a Minecraft. Maybe some I don't know. So you know you are not. Then so maybe in near futures we can create the virtual simulator for agriculture like a Minecraft. So I want to ask you, so what type of agriculture will you design using virtual reality? Terimakashi banyak.
Arigatou gozaimasu.
Arigatou gozaimasu.
Thank you very much, Sensei.
Thank you very much.
Very interesting presentation. Now we are in the question and answer session. I will give a chance for the participants to ask directly if you have any question. Maybe you could raise your hand and you could ask directly to Okayama Sensei. And also, if you want to type your question, please type it in the chat box. Okay. Mr. Andripat Pratama, could you open your mic? You can
Thank you
ask
very
directly.
much.
Thank you.
Thank you for the opportunity. I am Andri Pratama Arianto from Brawijaya University. I want to ask you one. I usually use the DJI mapper for mapping.
Oh, hi. Yes.
Some place like build a dam, a digital elevation model. Can it be used for micro one, like For example, a corn, because I want to generate it to become a 3D one and generate to augmented reality for counting how many corn in the field like that. Because it's very, very problematic in the harvest one, because when we got a order, but we can't afford that they order because some plant sick or maybe died like that. I want to generate it from 3D images become a to augmented reality to counting corn in field. Like, can it be done or something else? Thank you.
Yeah. Thank you for good questions. Yeah. So can you use a drone? Maybe corn is very high, isn't it? Maybe drone is very suitable for counting the number of the corns or to monitor the condition of corns. Yeah, augmented reality. So I mean, augmented reality is so augmented reality should be mounted on the head mount display in future. So the corn is very high. So I think it's a little bit difficult to capture the whole information of corns. Maybe you should use a drone. How about this?
Andri-san?
Yes. I get it. So use virtual reality in Google's like that, and counting down the amount of corn in the field.
Yeah, in the field. So I think it's a little bit difficult. So augmented reality is augmented reality. Yeah, I think it's a little bit difficult about corn because of the position of eyes. Maybe, yeah. Maybe, so if you, so the problem of the augmented reality is so how to get the position of your position, I think. Yeah, so to me, the current technology, I think it's a little bit difficult to get the condition of corns using some augmented reality devices. Still, I don't know near future. I'm sorry, so I don't think it's a good answer for you.
Okay, thank you very much.
Thank you very much.
Okay, thank you very much, Wakayama Sensei. We have one more question. One more person who would like to ask directly. He is Abamba-san from Kyoto University. Yes, Abamba-san. Hello, Abamba-san.
Konnichiwa.
Can you hear me?
Yes, Abamba-san is from Kyoto University, but is from Kenya, actually.
Kenya, okay.
Yes.
Yes,
Please,
yes.
Abamba-san.
Thank you very much, Dimas-san, Dr. Dimas, for that introduction. Professor Wakayama, thank you for that wonderful presentation. My name is Ken from Kyoto University. And it's very interesting that as we are moving towards maybe precision farming, that some of these technologies like 3D are going to play a very important role. I was wondering if, for instance, not just like the shape of the leaves, if it is possible to use such a technology to estimate like maybe the quantity of harvest. For example, by the farmer can be able to tell how much they can be able to harvest. For example, if it is a leaf vegetation, vegetables. So from the thickness, is it possible to give such information?
Yeah, thank you for your question. So my research is a little bit weird. So yeah, so maybe in order to get the yield or some other agriculture useful information, so maybe you should use a drone. And so using drone, and you can get the 3D information. Then maybe so you can calculate the mass of, for example, the corn or rice or some other crops. Then you can calculate the yield. Or yeah, I'm very sorry. So for example, as you know, that maybe so you should use a multispectral camera with a drone. Then you can get use an NDVI or some other indices to which has a good correlation between yields. I'm very sorry. So you should use such kind of technologies for estimating yield. Or so my technology is a little bit so weird. I'm very sorry.
Okay, thank you, Bambasang, for the question. Also, Kayama Sensei for the answer. We have question in the chat box from Dr. Ari. Making three-dimensional film images can be used for agriculture plant collection, both in size and color. But how about smell and taste of the leaves or fruit? Is there any technology to make?
Yeah, it's very, very good viewpoint. So so maybe so we are creating a virtual reality. So in virtual reality, so we should use the smells or some touch or other sensings. Yeah, it's a very good point. And electric nodes. So maybe there are some devices to capture the chemical components from the other, maybe. So in Ehime University, Nonami Sensei or some researcher research about the chemical component from the plants. Maybe if you use such kind of devices, so you can get the smells, or then so we can put the information of smell in the virtual reality. Then maybe so then this information can be used some simulation or some other.
Yes, maybe in the future, if you have sushi there, I can smell it from here through the virtual reality. Maybe.
Yeah. Good point.
Okay. Thank you for the
answer. Thank you for your questions.
Okay. Also, we have one more question in the chat box from Mr. Anwar Mujadin. What free software can be used in making virtual reality? Can OpenGL or OpenCV software can be used?
I'm sorry, so I will check.
So he is asking about the free software.
Free software
for making virtual reality and also 3D measurement.
Yeah, 3D measurements. Yeah. I use Cloud Compare. Do you know Cloud Compare?
Cloud Compare.
So I will check Cloud Compare.
Okay.
Yeah, Cloud Compare is a very good software to handle the 3D information. And also I use Houdini. Houdini is not a free software, but we can use some limited version can be used for free.
I see. For the virtual reality engine, is there any free software?
Pardon me?
For virtual reality engine software, is there any? Is there any free software for that?
I don't know. Maybe OpenCV is. I think it's good software. OpenCV. OpenCV is it's a very, very huge library. Maybe so. OpenCV. I think it has some library for augmented reality.
Okay, I also will check. Thank you very much, Kayama Sensei. So, is there any other question? Anyone who would like to ask directly? Mr. Ubaid? Hello? No one? So while waiting for the questions, I also okay.
My presentation is a little bit strange.
No,
I'm sorry. I'm sorry.
no,
I'm
no.
sorry.
I want to ask
Okay.
Hayama Sensei. Yeah, this is a very nice presentation. I have one question here. Is it possible for us not only to modeling the 3D model of kind of the agricultural system, but also to model the quality or the like the breaks or the sugar content or the internal parameters of the plant in the augmented reality? Is it possible for us to do so? Because I think it is very interesting if we do not just only simulate the physical appearance. However, we can also simulate all the internal component of the plants. So I think in the future we can set or we can customize our garden or our agricultural system, and we can also predict the result of the crops and the agricultural produces. I think this is interesting. However, the question is it possible for us to do so?
Yeah, of course, yes.
Oh, okay.
Because you are young. yeah. I'm serious. So because we have internet. So I think the whole information is on the internet.
Oh,
maybe
okay,
yeah. So yeah, you can and so maybe the free tutorial is located around the world, and maybe in the YouTube or for a free course of online course, maybe you can learn about such kind of technologies.
Oh, okay.
Yeah. But to me, it's so virtual reality is very equal to create games. Very equal, because so you can decide what world will you create, what kind of virtual reality will you create. The simple one is okay. If you maybe you can make a simple world, simple virtual reality is easily. So you can. So it is very difficult to explain, but so you have to decide the complexity or the size or how many factors you should input. Maybe the small size virtual reality can be created. So it means maybe Iqbal, so you can make some games very easily. I think it's only 1 week or 2 weeks. Yeah. I think to me it's the same concept. Can you understand? It's a little bit.
Yeah. I understand. Yeah.
Okay, thank you.
Thank you, Sensei.
Thank you for your questions.
Okay, any other question? I have question actually. Actually, previously you explained that when there is a stress in the plant that you measure, the number of point clouds is changed. So what happened? Why the number of point clouds change? Is it because the change of the shape only, or is there any characteristic of the plant that cause the point cloud change?
Yeah, thank you for good questions. So I think that the change of shape. So it's a controlled plants, point clouds of controlled plants. So they are there are no big change of shape point clouds. So there's no change in numbers. So here it's under source, the plants under water source. So so the shape is changing, so wilting, and so to me, so shape is more complicated. So if the shape is more complicated, the depth sensor cannot be sensed. So because lighting is not coming from the surface of plants.
Yeah.
So I think this is because of the decreasing the number of points.
I see. I just expect because it is a plant that get a stress, water stress or any other stress, and I wondering your system is using infrared light. Maybe is there any connection between the content of the water and the NIR?
So it's a very good viewpoint. So because your specialty of the so multispectral or some other chemometrics. I think it's a very good viewpoint, and so 3D points and plus and chemometrics or the infrared spectroscopy method is a very good viewpoint.
Okay, thank you very much, Takayama Sensei. Is there any other question? Baidila-san, please.
Thank you, Sensei. Actually, we may know that the physical properties of the agricultural commodities such as fruits and flowers, leaves, anything, its abundance and remain unexplored today. But for example, the dimension, the thickness, the shape, or anything from the commodity itself is not very remain unexplored actually. I'm wondering, is it the 3D measurement and modeling can be alternative method for to quantify the physical properties of the product? Because the traditional method, we measure, we use the traditional method, it's very tedious and actually it's very costly. And I think the future of this research is not only for the biological or agricultural aspect, but only not for to marketing the product itself. We can build the model, and at the same time we can send the model, the 3D, for the potential buyer for further info or further information about the product. So is it possible to replace the traditional method because the traditional method is very tedious, and we can replace it with your research? Thank you, Sensei.
Yeah, thank you for your nice questions. I think it's also, of course, possible, and thank you for your suggestion. So your suggestion is very, very, I agree with you then. So maybe, so yeah, if we get the very realistic measurement, for example, the very good, beautiful tomato or beautiful some strawberries, maybe so we can share the consumer or buyers this information. I think it's a very, very useful to for business or marketing strategy. Yeah, thank you for your
because the traditional one is not only give an information about thickness, can very abstract for the usual people to digest the information. But how if the common people can imagine, can virtually see the product about the flower, the
flower,
leaves, and anything. It's a very, very interesting topic to further to research, because the potential is not only for biology or agriculture, but only in marketing the product itself.
Yeah, I agree with you. Yeah, thank you.
Thank you. Ubaidillah Sang. And we have one more question from Amzal Sang. Nice presentation, Okayama Sensei.
Thank you. Konnichiwa.
I'm interested in the representation of 3D image of strawberry leaves in the slide. Since the environment is under artificial lighting, the spectrum is dominated by blue and red photon. Did the result would be different in case of outdoor strawberry farming? If we do the 3D measurement in outdoor, it will be different.
Thank you. Thank you for your questions. So, if you want to use a depth camera, so it is a little bit difficult to use outdoor because the sunshine includes the infrared a lot. So the too much infrared in the sunshine, it disturbs the measurement of depth camera sometimes. But so there are many ways. Different depth cameras that has a different way of obtaining depth information. But so some depth camera can be used outdoor. And the photogrammetry is just using usually using color information. So there is no problem to obtain the 3D information in outdoor. So is it okay for your questions?
So maybe outside for outdoor case we could use the photogrammetry. Is it the same?
Yeah, yes.
I see. Thank you for the answer. Okay, is there any other question? Anyone who would like to ask directly? Okay, Ababa-san again. Please, Ababa-san.
Sorry for coming again.
Yeah, no problem.
Okayama Sensei, I'm just wondering the shape of the leaf, as you've highlighted, that it will change depending on the water stress level of the plant. So, but in Kenya, especially in my home, it's raining regularly, so there's no problem with water stress. But there are some plants. There are some plants that change their shape. If, for example, you touch them, they will tend to shrink the leaves, and then maybe after some time the leaves will spread out, or maybe even there is a bird which just falls on it. So is it going to be the same tendency with this 3D and virtual thing?
Yeah. So yeah, it's good question. Thank you for your good question. So yeah, so I think that you read some research papers about the 3D measuring in agriculture. So that now we are researchers we trying to recognize or understanding the shape of the plants from the 3D informations. Maybe your viewpoint is a very good viewpoint, and maybe so in order to recognize the water stress condition of the plants in Kenya, maybe 3D information can be useful. But so it depends on the the resolution of the 3D point clouds. The leaf shape. So maybe it's a little bit. Maybe if you the images from the high altitude drones images, sometimes I think it's a little bit difficult to capture the small differences of leaves. But it depends on the resolution of point clouds, I think. Maybe so if you have a good enough resolutions, maybe you can get some information from the 3D models.
Oh, okay. So the best solution for such vegetation is using high resolution imaging, and also maybe to avoid touching them so that it do not affect their response.
I think so.
Oh, thank you very much, Sensei.
Thank you.
Okay, thank you very much for nice discussion. Is there any other question? Okay, if there are no more questions, maybe I will end the question and answer session. So thank you very much, Okayama Sensei.
Thank you very much.
Very nice presentation and nice discussion.
Nice discussion. Thank you.
I hope this guest lecture will be the starting point for our university and our laboratory also to work and collaborate in the future. Thank you very much, Okayama Sensei.
Thank you very much.
And
Thank you very much for joining.
I will give time to the Master of Ceremony again. Arigatou gozaimashita.
Arigatou gozaimasu.
Maybe you could end the slideshow, Sensei. You could end the share screen. Okay. Okay. Please, Rizkia.
Okay. That was a very amazing lecture. Thank you very much to Prof. Tsuyoshi Okayama for the sharing, and thank you Dr. Dimas Firmanda Ariza for guiding us in this lecture. It was a very long discussion session actually with interactive forum and interesting question from participants. For the next agenda, we will have a photo session. Before I close this session, I still would ask all participants make sure their camera is on, and for the participants who have not turned in the camera, please turn on your camera and use the background that the committee given before, and then prepare to best position and hold your smile for a moment. I will count 1, 2, 3, and you say cheese. Are you ready? Are you ready? 1, 2, 3, cheese. Okay, next slide. 1, 2, 3, cheese. Okay, next slide. 1, 2, 3, cheese. Okay, the last slide. 1, 2, 3, cheese. Okay, thank you very much. Now we are almost at the end of this event. Ladies and gentlemen, the last agenda is closing. I would like to thank our speaker and also all the participants. Hopefully all that we discussed today and provide benefits and can be implementation in our life. And I hope also this pandemic COVID-19 will not stop our spirit to also continue in learning and get college. I apologize if there was a mistake while being a host in this event. Thank you. Wassalamualaikum warahmatullahi wabarakatuh. Good afternoon.
Waalaikumsalam, bro.
Thank you.
Arigatou gozaimasu.
Thank you very much. Arigatou gozaimasu.
See you next time.
See you next time.
See you in Indonesia.
See you in Japan also. See you in Japan.
Yeah, in Brawijaya, in East Java.
Yeah, in Japan, Tokyo.
We will wait for you here.
Yeah.
After pandemic.
Pandemic, yes.
Yeah.
Okay, bye-bye. Thank you very much.
Thank you.
Okay.